Hanji, good evening. So we have to start with our session. So we were
Good
yesterday
evening.
doing softwares, right?
Ma'am.
So we talked about the evolution of software according to architecture, according to design, and according to languages, and right. So same way we were also talked about the types of software, system software, application software, programming language softwares, and utility software. Same way you also have perverse software also. And what are perverse software?
Malwares.
Yeah, they are your malwares or viruses which hinder your computer programs, which result in some modification or destruction of data in your program. So that those softwares are called perverse software. So they are also known as malicious software or malware also, right? So malicious software is also a perverse software which make your computer do something else, right? Or it corrupts your system, or it takes your sabotaging the operational system, right? So all those things are uh, how do we say sabotage? That they will have access to your system and they can do whatever damage to your system and all. So those kinds of things are known as perverse software. So malware can come into your system in any form through internet or through any medium, right? If you download some infectious attachments in your email, then also what happens is the software gets installed on your computer, and whenever you try to do something, some pop-ups or something, some vulnerability to your operating system happens. So all these softwares make your system do different things, right? So there are many infectious programs such as Internet Worm, MS-DOT virus. There are different kinds of malicious softwares or viruses which are there. So typical types of malicious software, if we talk about the perverse software, the types of pervert typical types are computer virus, computer worm, Trojan horse, rootkits, and spyware. Right. If you have to write about perverse software, so there are types of malicious software, which are these. First one is computer virus. You know about computer virus. It's a small software program that is designed to enter a computer without users' permission or knowledge, to interfere with computer operation and to spread from one computer to another. So suppose some software program is there. Suppose it is inside some pen drive, or it is inside through email attachment. It has come, whatever way it has come, right? It interferes with your computer operation, and from one computer, if you suppose you give your computer file which is infected to some other computer, or to some other person also, his computer will also get infected with the virus, right? So those kinds of softwares are computer viruses. They attach itself to a document or a program. They can do any destroy the files. They can destroy your software. They can uh, uh, cause loss of data also. So they replicate themselves. Viruses generally replicate themselves and do severe harm to your system. Right. So there are many examples or types of computer viruses that can be classified. Like they can, there are different techniques of attack also, modes of spreading also, forms of infection also, hiding location also. So there are different viruses which do different things. So for example, Randex, Melissa.a, Trojan.reboot, TRJ.reboot, there are different kinds of viruses which are there, whose example they have given. Then the another malicious software is computer type of malicious software is computer worm. So it is a program that is very similar to a virus. It has ability to self-replicate. It actively spread itself over the network, copies itself from one disk drive to another, or copies using email. It does not need user action to start it, unlike virus. That means what computer worms are, they can be on the network also. They can call, and they replicate themselves. That in viruses, what happens is you click on the particular file, or you bring that file into your system. That's why that virus spreads. But in worm, they won't. You don't have to do anything. They automatically come with whatever, some sites or some disk or some thing they come and they attach themselves and replicate themselves and make the system go berserk. Those are known as computer worm. And examples are PSW, bugbear.b, lovegate.f, trilil.c, sobit.d, mapson. There are different kinds of worms are there. So they does not need your user action to start. They will, unlike viruses, they will start automatically. And another one is Trojan horse. So when a program is disguised as something interesting and desirable, users are tempted to download. So you must have heard about the story of Trojan horse, right? Helen, in the story of Helen of Troy, right?
Yes,
So
ma'am.
Yes,
same
ma'am.
same way here also what happens is the virus hides itself in some disguised form, and you are interested to download or you are interested to install that on your machine by looking at that particular thing. And when you install that particular file or on your machine, so it deletes or makes your system corrupt. So that is a Trojan horse. So this is the typical technique of Trojan horse. For example, a file called saxophone.wav file on the computer of users who's interested in collecting sound samples may actually be a Trojan horse. Trojan horses, unlike viruses, do not reproduce by infected other files, nor do they self-replicate like worms, but they are extremely dangerous to users' computer security and personal privacy. So these are also, they are actually malicious intruders by allowing them to access and read files. So those are Trojan horses. So you are interested in downloading it, but when you install it, so it will make your computer do something else. Then you have rootkits. So this is a technique using which the malware remains concealed in the system and continues to do the damage in a concealed manner. Concealed means what? Hidden manner, right? So what happens is if this rootkit malware comes into your system, so it is concealed hidden and it continues to damage in a concealed manner. Rootkits can prevent a malicious process from being visible. That means you will not be able to see certain things in your Windows like taskbar. If rootkit virus comes in your system, so in Windows operating system, the taskbar will not be you will not be able to access the taskbar, right? And rootkit normally attempts to allow someone to gain control of a computer. So generally these viruses, what they allow is they allow someone else to access your computer. These programs are usually installed by Trojans and are generally disguised as operating system files. So yes, they are hidden inside the operating system files only, and you will not be able to find them, and they will normally control the system, and somebody else is controlling your system. Those are rootkit viruses, right? Then you have trapdoors also. This is a way of bypassing normal authentication procedure, Windows or operating system username and password to access the system. So there are certain viruses which can bypass your normal authentication, that is your username and password, to access the system. Once the system is compromised, impacted by the malware, one or more backdoors may be installed for easier future access to the system. So basically, once the malware is installed and bypasses your system, so they can backdrop your system anytime in the future also. They can access the system. So those kinds of viruses are trapdoors. Then you have logic bombs or time bombs also. So logic bombs are not programs in their own right, but rather camouflage segments of other programs. They are not considered viruses because they do not replicate, but their objective is to destroy data on the computer once certain conditions have been met. So what are logic bombs? They are not programs in their own right, but rather camouflage segments of other programs. So basically they are part of some other program. They are actually not a full program, but they are part of some program, and they are considered viruses because they do not replicate, but their objective is to destroy data on the computer once certain conditions have been met. So what happens is logic bomb or time bomb is like some condition is given that at this time or at this condition, the virus should start destroying the data. So that is those programs are known as logic bombs or time bombs. So logic bombs go undetected until launched, and the result can be destructive. For example, some malicious programs are sort of during days such as April Fool's Day or Friday the 13th. So there is a time bound action. When this day appears, then the data will start destroying. Those are logic or time bombs. Then you have spyware also. What are spywares? So we have discussed the malware intent to damage the computer. Spyware is designed for commercial gain. Right, they are designed for commercial gain. Actually, these programs gather information about the user in a concealed manner, show pop-up advertisement, redirect the search engine result to paid advertisement. Like yesterday, one person was telling now that I am getting this ad automatically on my system, right? So that is what they those are known as spyware. Right. So they are for commercial gains that they gather your information and whenever you and they are hidden, concealed, and whenever you open that particular application, so they pop up advertisements start coming and search engines or you have to install the search engines or whatever. So those are known as spyware. And then you have keystroke loggers, but they are not. They are actually they don't. Infect your system, but they tell you that you install this, you install that, so that they get their own money. Then keystroke loggers are, this is a program once installed on the system which intercepts the keys when entering the password of the credit card number. So you must have heard in news also sometimes that they have certain software installed in the ATM machines and all that, so that whenever you put your card and all that, so they interpret your keys and they will know your PIN number, and then they can swipe and do credit card frauds or debit card frauds, whatever. So those are known as keystroke loggers. So that is also a program, malware. And data stealing is another one. This is a web threat that results in stealing of personal and proprietary information to be used for commercial gains, either directly or via underground distribution. So some popular examples of recent data stealing cases are steal and sell large number of credit card numbers from businesses such as TJX, Office Max, Sports Authority, etc. So what is this? This is stealing of personal information and proprietary information for commercial gains, either directly or via underground distribution. So that is known as data stealing. So there are cases of credit card numbers being stolen and sold for money purposes. So these are the different perverse software types of malwares or perverse software which you have. So these are the ones which they have given. Then there are ways to counter these perverse software. Counter means that you want to get away with. How do you do these things? So ensure that the operating system and any program one uses are up to date with patches or updates. So basically what you have to see is your Windows should be updated. Do you understand? Security patches or your Windows security patches should be updated. So update your Windows as and when the updates come, so that you will get the latest. Like in Windows 10, you have Windows Defender, so it gets updated. So you are it will be able to catch the different firewall, and Windows Defender will be able to catch different intruders or viruses in the system. So update your operating system is the first one. Then block unwanted email viruses by installing a spam filter and spam blocker. So there are software or there are extensions of Chrome where you can have spam filter and spam blocker. So whatever unwanted email block, it will block the unwanted emails, email viruses which are coming in your emails. That is one thing. And when browsing the internet, always watch what one clicks and installs. So whenever you are installing something from the internet or you are browsing the internet, please see what you are clicking on, so that you do not install some malicious software along with what you want. So do not simply click OK to dismiss pop-up windows, right? So don't press always OK, just see what the pop-up is telling you to do, then either you cancel it, don't always press OK in that. Install antivirus software, scan and update regularly. It can in most cases remove and prevent viruses, worms, trojans, and depending on the software, some spyware. So you can also have antivirus software, you can buy that or you can have that and install on your system to be away from viruses and all. And install anti-spyware, anti-adware, scan and update regularly. It will remove depending on the software, prevent future adware and spyware. So there are certain adwares also which are for commercial purposes. So spyware and adwares are software is also there, anti-spyware and anti-adware. So they will also protect you from unwanted spywares and adwares which come. So these things you should do to prevent perverse software or malicious software to come into your system. That is there to prevent them. Right. Then we talked about open source software. So you know that open source software is a software that comes with source code. Right. It is not always that open source software means free software. No. It means that open source software generally comes with the source code. You will get the source code, and importantly also provides rights are typically reserved for copyright holders to study, change and improve the software. So basically open source software is they give you the right to change the code because they give you the source code, so you can change it, study it, or you can also improve the software. So this development happens in a large collaborative environment without any direct objective of the software commercial success. So that is what open source software is. And open source movement primary objective is to encourage innovation at the grassroots level, because there are one of the developer has developed some software, but if that source code is given to other persons who in the collaboration, so other person may have another thinking and he may add some kind of code which may make your software uh, more usable. So that because of innovation they have allowed to use open source as a movement, and it lets you develop individual talent also, and large companies also let you gain knowledge on particular software also, and reduce the software cost, because you will get the source code and you are yourself studying it, and you can change and improve the software. So it will reduce the cost for buying the license and all that. So improve quality and security. You can also improve quality and security also according to your own wish. Avoid forced lock into vendor proprietary software. That means you are not forced to buy any proprietary software or license. So you are not forced in that. So that's why they have made an initiative of open source software. Right now, they are more in the market. So open source initiative is a pattern of open source definition and is the community recognized body to evaluate and approve the software as OST compliant. So basically there is a community or there is a patron who say that this software should be an open source software. So they have some criteria, they evaluate and approve the software, that this software should be an open source software. So open source software compliance, to be an open source software, you should be what compliance you should have is free distribution. That means the license should allow any party to sell or give away the software as a component of a larger software distribution containing programs from multiple sources. So basically the license shall not require a royalty or other fee for such sale. So basically what is there, if a open source software is there, so the party who has the source code, who has taken the source code and manipulated according to their own changes they have made in the software, they can resell it according to their will. There is no royalty or other fee for all these things. So they can also sell their license key and give that. Then source code is given free. So the program must include source code and must allow distribution in source code as well as executable form. When some form of a product is not distributed in source code, there must be a well publicized means of obtaining the source code for no more than a reasonable reproduction cost, preferably. So basically, downloading via the internet without charge. So basically, source code should be given. If it is a open source software, the source code should be given so that if it is not given, it should be publicized that no source code will be provided for this kind of software, and they should announce it beforehand that there is no source code for this open source software. Right. Then derived work, the license must allow changes to the existing source code and must allow them to be distributed under the same terms as the license of the original software. So basically, the license, if if you want to do some work on the particular software, so they should allow the changes to the existing source code. The license should allow that, and under the same terms as the license of the original software. So the source code is changeable in your open source software, that it should allow, and no discrimination against specific applications. That means the license must not restrict anyone from making use of program in a specific scenario. So whatever way a person wants to use that particular software, open source software, there is no discrimination. They can use in any specific form. Right? For example, it may not restrict the program from being used in a business or from being used in drug research. So if your program is being used in business, that is also allowed. If it is being used in drug research, that is also allowed. There is no restriction. And license must not be specific to a product. That means the rights attached to the program must not depend on the program being part of a particular software distribution. So the rights attached to a program, they are not dependent on the particular software distribution. So the license must not be for the specific to a product only. So license can be distributed, or license can be given separately for separate programs also. License must not restrict other software also. So license must not place restriction on other software that is distributed along with the license software. Right. So that means if you are giving a license software and other softwares which are not licensed, so they should not have any restriction on other software also. You can use both of them. For example, the license must not insist that all other programs distributed on the same medium must be open source software. That means if you have bought a open source software license, and it should not restrict the other, that all other applications which you install on your system should also be open source software. These kinds of restrictions should not be there. So you can have proprietary software also, you can have open source software also. So these kinds of things will make an open source software. So what are the different examples of open source software? You have PHP, that is scripting language suited for web applications. So web applications can be made with this language. Operating system, what are the different operating systems which are open source? That is GNU project, a sufficient body of free software, and Linux. Linux is an operating system which is under open source software, right? So Linux is based on Unix, right? The other one is server software. So server softwares are your Apache for HTTP web server, Tomcat web server, MySQL is a open source database. It is used for database, and MediaWiki, the wiki server software, the software that runs Wikipedia. That is also a open source software. And client software are your web browser like Mozilla Firefox, Mozilla Thunderbird email client. So these are your open source examples of open source software. Then open source.
Yes, ma'am.
Yes. So in the open source software, you also have, like, for example, Red Hat Linux. Have you heard about that? A company, Red Hat, is making Linux. So that is one distribution of Linux. So they sell Linux operating system and provide product support training as well. Right. So they are selling, they have made the source code of Linux their own, and the Red Hat Linux, the Red Hat company is making that Linux, and they are giving the license. They are redistributing the license and providing support and training as well. So those are also open source software. So the open source software is not always the best option for all the business needs, but there are businesses which are running on open source software, right? So these are the different things you have of open source. So is there any doubt in this software and types of software and perverse software, open source software, right? Is there any doubt?
No, ma'am.
No. No.
Right, so this was your unit 1. So you also have check progress questions. I told you at the end of every chapter you have check progress question. Please practice those questions. So they are from your content from your book only. So now we go to the second unit of your So we are going for the second unit, that is operating system. So we have already studied about what is an operating system, right? It's a software which is a interface between the user and the hardware, right? So user interacts with computer through the operating system in order to accomplish his or her task. Since it is his or primary interface with the computer, it helps users to understand the inner functions of a computer very closely. And many concepts and techniques found in the operating system have general applicability in other applications. So this is just a general view of the operating system. So the concept of operating system is essentially to support all the hardware and software components in the system. Right. So we define an operating system as a large collection of software which manages the resources of the computer system, such as memory, processor, file system, and input-output devices. So basically, operating system is a large collection of software, right? Which is managing all your resources in the system, like it is managing the memory, the processor, the file system, the input-output devices, everything it is managing. Right. So how each resource is it is keeping a track of each resource, the status of the resource, and how long and when the resource is working or your hardware devices are working. So it provides two basic type of services. It accepts requests from users, and from users program and execute their command. Basically, what operating system do is it takes the request from the users, right? It optimally manages the hardware resources. The other work it does is it manages all your hardware resources, which are your CPU, your main memory, hard disk, input output devices, and whatever are your hardware devices. It is managing them. So, every work is managed by the operating system, right? So it is also a command interface. Why it is a command interface also? Because whatever command we have to give, the user has to give, it gives on the operating system only. Yes or no? Whether the user clicks, whether he is executing, whether he is doing what, double clicking, whatever he is doing, he gives a command. It's a command interface. It's an interface between the user and the hardware. So it accepts a command from the user through mouse clicks or from keyboard through a port number. It is able to recognize what is the source of input. It must interpret these commands and take actions accordingly. It must provide a file system that can interpret the name of the program being requested and determine the location of the file on secondary storage device, for example. It must read the appropriate blocks from the device into memory. Only then can operating system transfer control to the program being executed. So basically, even if you have to save a file in a particular location on the secondary storage device, then also the operating system will handle that. And if you have to read a particular block from the device, then also every transfer and everything is handled by the operating system. So this is the main interface. Without operating system, your system will not work. You will not be able to interact with the computer. So operating system provides interface from user keyboard, mouse, clicks, and pen drives, and also from user programs. So it provides file system support to manage huge volume of data into secondary storage device. It provides input-output services that can be used by every program. It provides bootstrapping or initial program load to start a computer. So when you start a computer or boot your computer, bootstrapping it is called, or you can say IPL, that is initial program load. So that is also provided by the operating system, right? It manages all kinds of errors and also supports error recovery mechanism. It provides networking services. It provides the environment or location of memory, input output devices, CPU, concurrent processing. You can say multiple processes or multiple programs are being run. So as you are aware, a single processor is capable of executing only one instruction at a time. So concurrent processing is a means used to simulate the simultaneous execution of multiple programs to provide multitasking and multi-user support. So if you want to open multiple tasks are open, how you are doing multiple programs are open, how you are doing it through concurrent processing, right? So that is also done by operating system. So there are two operating system is commonly divided into resident and non-resident part. So some operating system services are critical to the operation of the system and must be resident in the memory all the time. So basically, some of the operations of the operating system will be on the memory. That is your RAM. That is resident. and some other can be loaded into memory only when they are needed, and some of the part of the operating system are when they are needed only, then they will be loaded. So that is known as non-resident parts. So these two parts operating system is divided. Then also the critical programs are loaded into memory by the bootstrap loader at startup time and will remain resident as long as the computer is running. So bootstrap is your booting when your booting information is all loaded into the system. So that critical program at the startup time will remain resident as long as the computer is running. So that will be in your memory. So bootstrap for most modern computer is stored in read-only memory. So you should know that the booting information or bootstrap is in your read-only memory, that is ROM. On some computers, part of the resident operating system will also be contained in ROM. So in some systems, ROM also contain resident operating system also, so that it is permanently resident in memory and always available for use. So in some system ROM has operating system also. The memory resident components of an operating system are commonly known as kernel of the operating system. So always your kernel is the brain of the operating system, you can say. The heart and brain of the operating system is the kernel. So the kernel part of the operating system is always resident on the memory, right? For example, the operating system program accepts user commands must always be present, as well as the programs that handle requests from user systems and manage resources in a multitasking system. So they should always be in the memory. So those parts are kernel and they will always be in the memory. So on the other hand, an operating system command that formats a new disk is only used occasionally. So whenever you need to format your disk or format your hard disk, so that part of the operating system is not always required. So that will only be loaded when it is required. So that is non-resident. So it can be loaded and executed when it is required. Today, the trend is towards design of nano kernel or micro kernel. Essence of these kernel is to keep the basic kernel smaller. So basically, the main heart or brain of the operating system is the kernel. So nowadays, the design of nano kernel or micro kernel is being made so that we are making the kernel smaller, which will take less space and will be more faster. So there are most things which are there. For example, some examples of operating system they have given: Unix, Windows 2000, Windows XP, Linux. Nowadays you have Windows 10 and 11 is also come, right? The latest. So these then you also have Macintosh also, that is Apple's computers operating system. That is also an example. So your operating system can do what? What are the features of an operating system? Operating system can be a single user, can be if we talk about types of operating system, it can be single user, multi-user, single tasking, multitasking, multi-programming, right? Real-time operating system. So we'll talk about that when it comes. So there are different types of operating system also. So you have online interactive systems also, so that is also there. We are not talking about that. So this is what, and now earlier the operating system was CUI, that is character user interface or command user interface, you can say. And nowadays it is graphical user interface, GUI. You have icons and all that, and you can click on that. So it is GUI, right? So here we are talking about operating system services. What all services does the operating system give? So you have command processor and user interface, file management system, input output control system, process management, memory management. These are the features of the operating system also, the services or features which the operating system provides. So it is a command processor because it is an interface between the user and the hardware. So it processes your command and provides the user interface also. And it also manages the file. So it is file management system. It manages the input output devices or controls the input output devices. So it is input output control system. And every program which is in running mode, a program in run mode is known as a process. In operating system, every program which is running, which is executing, is a process. So all the processes which are currently executing or running will be handled by the operating system. So that's why process management and all the memory management things, or to save or to bring to RAM, or to save in the hard disk, whatever it may be, are handled by the memory management system. So these are the services which the operating system provides you. So command processor and user interface, I've already told you that to the user, the most important and visible services provided by the OS is the user interface and the capabilities that it provides to execute commands which may not be a part of OS. So that is there. Then it is also providing you GUI, graphical user interface. Earlier it was command line interface, right? Then it is also handling your file management. The concept of file is, do you know what is the difference between a file and a folder? What is a folder and what is a file? Anybody knows?
File is just a single thing, and folder can have multiple files.
Yeah, but file is having a content. Any
Yes.
file will have a content, but folder is only having is a container. Folder is a container which is holding other files of folder. Do you understand?
Yes, ma'am.
Right. So that those things are handled by the operating system. So file management also it does, where you are storing it, what is the size of the file, what type of extension of the file is there. So all these things are managed by the operating system. So you have to give the file name, the extension, whatever is there. So that is also there. So then it also provides input output services. Input output services like all the input output devices, device drivers which are also there. So it interacts with the device driver, which device is giving what, whether information is coming from the input device and going to the output device. So all are managed by the operating system. Then I told you about process. Process is an executing program or program in execution. So every process or program which is being executed, all the processes are being handled or managed. How they synchronize it, which process should be run first, which process should be run later. So all things are managed by the operating system. Then it also does memory
Then
management.
actually, I have one doubt. Like, how can we differentiate between like input devices and output devices?
How do we differentiate? We have
Between input
already
devices
discussed
and
that what
output
are the
devices.
different input devices. Those devices which from outside, which take data from outside, goes into the system, is input devices. Like keyboard,
Like,
you are giving input to the system. Do you understand? I am clicking
yes.
mouse, by clicking the mouse, I am giving input to the system. So those are input devices. Scanner, I am taking a printed copy and scanning it and putting it inside the system. It will go. So that all those devices which are taking input or data from outside are input devices, and all those things which take output means which are taking data from the system to the outside world. Right? Just hold on for a second. Right? Do you understand? Now can you differentiate between our input and output?
Yes, ma'am.
So output devices are those from the system the output data is coming out. Like on the monitor you see the result, or from the printer the paper printout comes. System has the soft copy and the printout comes on paper. So that the printer does that now. Data is in the system and data comes out. Do you understand? All those things where data inside the systems comes out in any form, like if you hear a sound, speakers are output device. Your sound file is in your system, and when you play it, the sound comes from the speaker. That is an output device. You understand?
Yes, ma'am.
So operating system manages those input and output devices. Right. So we talked about processes. Then memory management it does. Right. It manages all the memory, which memory to be loaded, which is to be accessed. right? Which where your particular file location is there, which file has to be accessed, and all these things are handled by your operating system, right? So it does file management, memory management. It is a user interface, command interpreter, right? Process management. So all these things are the features or services of the operating system. If we talk about the history of operating system, so over the years, operating system also has been developed. It has also evolved. First when earlier years were there, when 1940s or 50s was there, so serial processing was done. What is serial processing?
One thing happened after the
Yeah,
another.
one by one, everything happened. There was no direct processing. Serial processing was done. So the programmer interacted directly with the computer hardware. At that time, binary language was used. There was no operating system. So directly with the hardware, they used to communicate. These machines were run by operators from a console consisting of display lights, toggle switches, some form of input device, and a printer. Program in machine code were loaded via card reader. So those were serial processing. Right. Gradually, after this, various system software and drivers and all that were later on developed, and then simple batch systems were created. What does batch systems do was uh, number of jobs. Suppose you have for a print job, or number of jobs were collected in one batch, and they used to run it in a batch, and then until the batch that job batch is the all the jobs in that batch are completed, the system could not do anything else. So for until that job is completed, the system is just running those batches. So early machines were very expensive, and therefore it was important to maximize machine utilization. To improve utilization, the concept of batch operating system was developed. It appears that the first batch operating system and the first operating system of any kind was developed in the mid 1950s. So in 1950s, actually, your first batch operating system or any operating system was developed by General Motors for use on an IBM 701 system. So the concept was subsequently redefined and implemented on IBM 704 by a number of IBM customers. So the central idea behind the batch processing system was the use of a piece of software known as the monitor. So with the use of this type of operating system, user no longer had direct access to the machine. Rather, the user submitted the job on cards or tape to a computer operator who batches the jobs together and sequentially and places the entire batch on an input device for use by the monitor. Many important breakthroughs in operating system design occurred in the early 1960s. So basically what happened was number of jobs were collected and they were put in a batch, and the batch was run and sequentially the jobs were getting executed. So that kind of a system was batch processing system, right? That was developed later on. Again, more development came into being after 1960s, and many other multitasking capabilities, multiprocessing capabilities came into being. So IBM introduces OS 360 as the operating system for its new system 360 in 1964. So OD 360 provide a powerful language expedite batch processing job known as job control language. It introduces simple form of multi-programming or multitasking feature. So these kinds of developments were going on, multi-programming and multitasking features were coming into thing. Then came time sharing system. So what does time sharing system is? It is a kind of a multi-programming system, right? Uh, So after batch processing came time sharing. So it is a kind of multi-programming system or multi-user system. So suppose you have a server and many users are connected to a server, right? So you have to share time between those users, right? So they have some time period where each job will be according to those that time period, and so that kind of a system was time sharing system, right? So some jobs such as transaction processing and interactive mode is essential. So many jobs require that the user interact directly with the computer, or often they will have certain time limit for correction. So instead, time sharing was developed. Just as multi-programming allows the processor to handle multiple batch jobs at a time, multi-programming can be used to handle multiple interactive jobs. In this later case, the technique is referred to as time sharing because the processor time is shared among multiple users. So what happens is you are sharing the processor time among multiple users, and in time sharing system, multiple users simultaneously access the system through terminals, with the operating system interleaving the execution of each user program in a short burst of quantum of computation. So basically, in a time sharing system, you are attached to the server, right? You are doing some programs or you are accessing the server, but your execution time, you are not able to see it, how the operating system is handling it. But in a time sharing environment, it is executing your program, and it is seeing whose program to execute first and whose to execute next. So you will not feel the time burst, but there will be a time burst, a short burst of time in which it will execute your program. So that kind of an environment is time sharing, right? So that is there, right? So these kinds of things are there. Other kind is there. Real time operating system is also there. What is real time operating system? You must have seen like what I tell you, you must have seen the air traffic control. What does air traffic control do? Suppose two of the flights are coming from separate direction, but at the same altitude and same level from opposite sides. So if we are not telling one of the aircraft to lower itself or to change the direction or altitude or whatever, so what will happen? They will get crashed because they are coming from the opposite directions and the same altitude and same level, right? So air traffic control does what? It manages the air traffic and tells one of the flights to change its direction or to lower to a certain level, whatever, right? So that these kinds of things, or suppose there is an atomic research thing where nuclear research or something where some kind of nuclear reaction will happen in some time. If within that time that reaction or that particular thing doesn't happen, so a blast will be there. So what these real-time operating system does is, within that time limit, they have to answer or they have to respond to the particular thing, so that a mishap or damage is not happened in the system. So that kind of a thing is real time. So that is also one of the things. So later on, Unix was developed, right? So digital PD7 mini computer, on that Unix was developed first. So Unix was the one of the operating system which was developed in the early 1960s, I think. So development of personal computer operating system was occurred in 1982 with the introduction of IBM personal computer. IBM PC was designed as a standalone single user computer for mass market. IBM PC was supplied with a reasonably easy to use operating system, PC-DOS, which was developed and also later marketed by Microsoft as MS-DOS. PC-DOS was actually derived from an earlier personal computer operating, right? So all these were your IBM IBM developed the operating system, standalone operating system, IBM PC, or your DOS was developed as Microsoft developed MS-DOS at that time. In 1980, 1990, your the evolution of MS-DOS was there. From MS-DOS, you had gone to Windows 3, Windows 95, 90. Then came Windows 2000. So now you have GUI based graphical user interface. Now it is, and Unix that was developed in 1980s or 1970s, 60s or 70s. Unix was developed, and later on the development of Linux was there in 1980s. The newer version of Unix, or you can say a graphical version of Unix, is Linux. So in 1980s, that was also developed, and also Mac, that is Macintosh for Apple computers, was also being developed at that time. So this was coming into creation. Then Java virtual machine. What is Java virtual machine? So that is your JVM, which lets you have machine independent. That means on any network or any machine, your Java applications or Java programs can be run. So that kind of a system was also developed. So this was all about operating system, right? So is there any doubt in this? You just need to know what is an operating system and what are the types of operating system. These are the things you need to know. And what are the services or applications provided by the operating system, right? Any doubts?
No one.
Right, so this was your unit 2, that is your operating system, and the other unit is unit 3. This is we are doing block 2. Right, now comes the concept of programming language. So we all know that programming language is used to design and describe a set of instructions and computations to be executed by a computer. So all the programming languages, what they provide us, that we can write our set of instructions, make programs, and we can execute it on the computer, right? So programming languages, first learn a programming language, first and foremost, we need to know two important parts. A particular programming language syntax we need to know, which suppose C, C++, whatever language we are using, we need to know the syntax of that thing, how to write that program in that in that language. An algorithm to solve the problem, that means you need to know the algorithm, or algorithm means the finite number of steps, the steps which you want to perform, so that you can get the output, or you need to get the output or desired output what you want. Algorithm is a step-by-step sequence of operations which or instructions written in English language, which you will implement in your program, so that seeing the algorithm that these steps I have to take, so you will write those steps in your programming language. So first you need to know the programming language, then you need to know what how to write the algorithm of that program. So that is the two important things. So program is defined as a collection of statements generally, or instructions you can say. So you need to know what is the first, you need to know what is a problem. What is a problem? In normal English, what is a problem? Any particular task which we need to solve, right? Yes or no? Problem is
Yes,
a
ma'am.
particular task which we need to solve. So same way in computer programs also, when we are writing some programs, every problem is your task which you need to make a program for. Right. For solving the problem, some input has to be given to the system, and the system will manipulate the input and give you the desired result. So this is what happens. So to describe the steps, what steps need to be taken, we have to write algorithm. So first important thing, while learning a programming language, you should learn what is an algorithm. So, algorithm is a step-by-step implementation of your program in English language. So once a problem has been defined precisely, a procedure or process must be designed to produce the required output from the given input. Since a computer is a machine that does not possess problem-solving judgmental capabilities, this procedure must be designed as a sequence of simple and ambiguous steps. So basically, if you see a computer, until and unless you don't provide any input and you don't give any thing, would the computer do anything? It is not intelligent enough. It will understand what you want. So you have to give the input. You have to tell the computer that these things have to be done. So to make that steps, you need to write a procedure, or you need to write the algorithm for that. Right. So that is the first step in learning a programming language. So we need to write the steps, what all things the computer needs to do, or the program needs to do to get the desired result. So algorithms are designed using three basic methods of control: sequential, decision or selection, or repetition. What is sequential? Either your algorithms are sequential. Sequential means step-by-step sequence of instructions are there. Those one by one the program will execute. Right? One is sequential. Or you can have decision or selection. That means one alternative, several alternatives are there. If this condition is true, then this will happen. If this condition is false, then this will happen. That kind of a thing is known as decision or selection. right? So that can also be done in algorithms. And repetition, what is repetition? That one or more steps is performed repeatedly. Some of the steps you need to perform repeatedly, that is known as repetition. So in programming language, sequential so simple steps are there, but when you talk about decision or selection, you have if and switch. In C, if we talk about in C language, you have if else as the decision maker, and selection is switch case, right? And repetition in C language is loops. Repeatedly in loop, some statements have to be done, so that are loops. So we are just talking about that. So these things you have to implement in your algorithms also. So program to implement algorithms on the computer must be written in a language that the computer can understand. So now you have written suppose you have written the algorithm, you have taken these repetition or whatever decision making or sequential, whatever form you have written, then those programs the algorithms have to be implemented into a program in a language, in a computer language which the computer can understand. So it is fruitful, therefore, to describe algorithms in a language that resembles the language used to write computer programs. So this is called pseudocode. So sometimes you also need to write pseudocodes which is similar, which resembles your programming language or computer program language also. So that is known as pseudocode, but not completely your programming language code, but resembles the programming language. It is not a programming language with a rigid syntax, but is similar to the one. So this idea is that it should be easy to write a program by looking at the pseudocode. So idea is that if you look at the pseudocode, it will be easy for you to write a program in your programming language. So that is one thing. So how the other part of the thing is you should also have a pictorial representation. What is pictorial representation? If you see a picture of something, a problem, then you understand that the problem solution in a picture, then you understand more clearly, right? Picture format is more clear than a written format. So that's why flowcharting, a flowchart is another concept. So flowchart is a graphical representation of an algorithm. The algorithm you have written step by step in English language, and that is represented graphically. That is a flowchart. So algorithm can be represented graphically. So that is a flowchart, or you can say a blueprint kind of a thing. So what are the different basic symbols in a flowchart? You have start and end. This is an oval symbol, this kind of a symbol. Process, that means some computation or some calculation. What you do is square rectangle box. Input output, that means you are giving input or some output is coming out. So that is a rectangle with a slanting sides are slanting. So that is input output. Then you have decision making box or decision box, which is if you have condition that this condition is if true or false, so you have this diamond kind of a box. And flow direction, that means from start to go to process to go to input, something like that if you want to show. Then flow direction is your arrows with lines. And connector means if in one page your flowchart is not fitting, you have to take it to the second page, then this kind of a connector you have to show on the first and second page. So that is also there, right? Now first we need to write an algorithm, simple algorithm. So suppose to find out whether a given number is even or odd, they have given you that we need to find out first. We should do some simple algorithm first. Suppose I want to find the sum of two numbers. Suppose this is my problem. I need to find the sum of two numbers. So algorithm for this problem will be step one. Right? You can write like this. Step one. First and foremost, what do I have to find out? I have to find out the sum of two numbers. So how many variables I have to take? Two. So I can write input two numbers, right? Yes or no?
Yes, ma'am.
Yes, ma'am.
I'll take two numbers as input. I'll input two numbers. Then step 2. Now I've inputted two numbers. Now I have to add these numbers. To add these numbers, you can take another variable also, or you can simply write add the two numbers, right? Like this also you can write, or you can write C is equal to A plus B. I'm just giving an example. So A and B are the two numbers. So you can say input two numbers A comma B. So these are the two numbers you have input, right? And in C you have added those two numbers, right? Now step 3, what will I do? I will print what?
C.
C, the sum, right? And step, acha, I have one, chalo, theek hai. So this is my final answer, right?
Yes, ma'am.
Yes. So now this is the algorithm. Now when we talk about the flowchart is a pictorial representation of the algorithm. Now the pictorial representation, first and foremost, I'm just taking the shapes. So you have flowchart options here. So first I need to start and stop one I have to make. So this is not an oval. So first inside this I'm making start. First I'm starting my flowchart. So this is start, right? Then I need to input two numbers. I need input output box. Do you understand? What is your input output box in your this? Yes, a slanting rectangle. Can you see that?
Yes, ma'am.
So take an input output box which is slanting one, which is this. So this I have taken.
Parallelogram.
Yes, and I'll say input A comma B, right? And I can connect also with the arrow. After start it will go here, right? Next, what is there? Now I have to process the data. That means add the two numbers, right? So for the processing, what box is there? This is there, a simple rectangle, right? So just take a simple rectangle. So this is your processing box. So here you will calculate C is equal to A plus B, right? Connect it. After taking the input, you will calculate the sum. So this is there. Then after calculating the sum, what you have to do? Print C. Print means output,
Yes, ma'am.
right? Right. Again, you have to take the input output box. That is your slanting one, or this one. So I am saying print C, and I'll again connect it. After the sum, I'll print the output. So that is there, and at the end, what will I do is stop. So now my program is over. Do you understand how to make a algorithm and how to make a flowchart for that?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Right? So this is how you make a flowchart, and this is how you make a algorithm. Do you understand? Is anybody having doubt?
ऊपर से
Hanji, Harshit, what happened? Right. Acha, now tell me, suppose this problem is given to you, which is this example 1, to find out whether a given number is even or odd. Right? So tell me, how do you find out a number is even or odd? Just tell
Even
me the
number are
logic.
divisible by 2.
Yeah, those numbers which are divisible by 2 are what?
Even.
Even. And the others are?
Odd.
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 Right. So, what will you do? First of all, what will you do? You have to check the remainder, na?
Yes,
If you
ma'am.
divide the number
Yes,
by
ma'am.
2, the remainder should come out to be what?
0.
0. Right. Then it is an even. Otherwise, if it does not come out to be 0, then what is? It is
Odd.
odd. So see what they have created. Your step 1 is start. I have not put here in my here start and stop. You can put here step 1 start and step 4 stop. Right? You can
Yes,
do
ma'am.
that. No problem. So step 1 is start. Step 2 is input the number n. Why I have taken input the number n? The number I will be giving for finding
इस बारी
whether
पापा
it is
पूरे बड़ा फेर
even
पाना
or odd.
गा तो आई पहला गा बन्नी मल्ले देंगी तो खड़ोती नहीं बहन
Harshit,
दे ताजा पान नंदन हम पे खड़ोती नहीं फिर बैडू लंदा बैडू बनने आ कहां तो आई बहन बननी दोबारा पटिंगे च
where is Harshit?
बननी आया मैं दोबारा फिर मतलब थोड़ा ही पानी है ना
बहुत देर बाद तुम्हें समझ में आ रहा है. आई एम टेलिंग यू टू म्यूट योर माइक. यू आर डूइंग इट राइट नाउ. हाँ जी. So step 2, we are inputting the number for which we have to find out whether it is even or odd. We have input n. You can take a, b, c, whatever name of the variable you can take. So they have taken n. Then step 3, now we have to find out the remainder. Find the remainder on dividing the given number by 2. That means you have to divide n, the number, by 2 and find out the remainder. Right? Yes or no?
Yes, ma'am.
And if now we are giving a condition, if the remainder is equal to 0, then print number is even, right? Else, if the remainder not comes out to be 0, then print number is odd. You don't have to again give if, because one if is okay. If remainder is 0, then this. Else, if it is not 0, then odd. Do you understand?
Yes, ma'am.
And end. This is my result, right?
Yes.
And how to make the flow chart for this program? See, this is your flow chart. You'll start your oval. In the input output box, you have given input a number n. This is your condition box, right? We have seen now. The condition box was this diamond decision box. So this is your condition box. So you will give if n percentage 2 is equal to 0. What is percentage symbol here means? In C, percentage means
Remainder.
modulus. Modulus means it which gives the remainder. Do you understand?
Yes,
Modulus divides the number but gives the remainder. It will not give you the quotient. It will give you the remainder. Right? So if n, that is your number, modulus 2, that means divided by 2, but answer will be remainder is equal to 0 means this is an equality operator. Double equal to is an equality operator. So if n modulus 2 is 0 and it is equal to 0, 0 is equal to 0. If it is yes, then out in the output box we are saying print n is even. If it is not equal to 0, then in no we are saying print number is n is odd. Right?
Yes,
And
ma'am.
then we have to stop. This will also come to stop. This will also come to stop. Any doubt?
No, ma'am.
And
Ma'am,
if
this
we have,
example
yeah,
is done with Python language, no?
no. Python also has the same similar kind of operators as in C.
It's a pseudocode.
What is a pseudocode? What is a
Well,
pseudocode? What you are
in
telling?
example,
Which example? This?
which you are talking about,
Yeah, I didn't understand. I talked about what pseudocode. What example I gave?
I am saying, ma'am, it's like a pseudo code.
This flowchart.
Yes, ma'am.
It's like a
Inside.
pseudocode only. Right? Through this you can write your program, na? Final program you can see and write it. Right? In any language, whether it is Python, whether it is C, C++, whatever language, Java, whatever, you can see the algorithm of flowchart of the program and you can write the program, right?
Okay, ma'am.
So if we have to implement
Ma'am,
this
can you
in C language,
explain?
yes.
Can you
बोलो
give
क्या explain
the
कर
example of connector, ma'am?
example of
Where we can use connector?
connector is
Connector, ma'am.
generally not used. Connector is only used if your program is too big and your flowchart is not covered in one page. It is not, but suppose it's so much big program and the flowchart is not taken in one page, so you want to have it on the second page also. So to make a connector, that means the connector tells you that the second page is also there for this flowchart. There you will use a connector, but it is rarely used because so long flowcharts we don't make. Do you understand? Do you understand why connectors are used?
Yes, ma'am.
If you have such a big program where you're in one page your flowchart is not fitting, then on the second page you need to show that connector is there. That means second page is also there for the flowchart. It is not finished yet. Right. So if we have to implement this program in C language, now seeing this algorithm and flowchart, see, first and foremost in C language, you have a header file. Hash include is a preprocessor which tells that this header file, this is a library file. Inbuilt, there are some inbuilt functions in the library file which you need to use in your program. So there, the first line which we write in the C program is hash include in less than and greater than brackets stdio.h, that is standard input output file, header file, which has printf, scanf functions and all. So these header file we include, and slash asterisk means comment. Do you understand what is comment? And asterisk
Yes, ma'am.
slash in between this we are giving a comment. This will not be compiled by the compiler. This will be taken as only for your reading. You have given that it will not be compiled or it will not be taken as the syntax of the program. So first line we will write this to include our header file. Then is void main. Main is the function. Function means a set of statements. So each C program has a function which is main. It should have a main, right? So void main means it will not return a value. Void means which does not return a value. If there will be a data type here, int or something, then it has to return a value. So void means it will not return a value. Then after main, circular bracket should always be there. Every function which if you define any function, it should have circular brackets like this, opening and closing parenthesis, and then curly bracket. After that main, you will have curly bracket, that is opening of the body of the main, right? Then again a comment is given to mark beginning of block they have given. Then they have declared a variable int n. Int is integer, that is a data type in C, and a variable n is declared, integer n is declared. Why I have taken an integer n? Because I need to input a number and a integer number. That's why int is the variable and n is the name of the variable, and semicolon you have to put at the end of, in the body of your main. Every statement will end with a semicolon. Do you understand? Right. So this is ending of
Yes, ma'am.
this statement. Then this is comment again that we have declared a variable. Then printf is the function for printing a particular text. So printf is in this stdio.h header file. This is containing this printf. So this is a predefined function which will help you to print any text or any line you want to print. So printf, inside printf, in circular brackets will be there, and in double quote, any text or any alphabets you have to give in double quotes. Right. Always remember, when you have to give in, you will not learn C here. You will learn C in the second semester. But I'm just telling you that in double quotes only your text will always be given in double quotes. So enter the number we have given. That means first statement when this program will be executed, it will ask me enter the number. So again, at end we have given semicolon to end the statement. Here again comment is given that predefined output function in header file to display the message or standard output device. So they are saying this is a predefined function for printer which displays a message or whatever sentence you have given, it displays on the output device, that is your monitor. Then scanf is another function in the standard input output header file which takes input from the user, right? So here scanf is the function and the circular brackets, and in double quotes we have given %d. %d is a format specifier for integers. That means we need to take input, integer input. So %d is that, and comma ampersand n means, ampersand means the address location of this variable n. At this address location put this value with, so when this message will be displayed, enter the number. After that it will wait for your input. Whatever you give, 5, 6, 7, whatever number you give will be put in the n, would be put in this variable n. So that is scanf. Input is taken, integer type input, right? Then after this again semicolon to end the statement, and next is your condition. Now you have to check the condition. For condition checking you have if. So if, now we are giving the condition in circular bracket n modulus 2, that is n divided by 2, modulus means it gives the remainder, is equal to 0. That means if suppose my input I have taken 5 divided by 2, it will give me the remainder as 0, or 1, it will give me the remainder as 1. So 1 is equal to 0? No, right? So 1 is not equal to 0. So here semicolon will not come, because if condition you have the body of the if. So curly brackets is the yes part, this curly bracket is the yes part, else, and after else is the no part, right? So if n modulus 2 is equal to 0, that means 0 is equal to 0. If it comes, then it will print f number. %d means integer, here the number will be printed, 5 or 6 or whatever number is given is even, comma n's value, here it will be printed 5 or 6, right? Else printf number %d is odd. That means number, if 5, 4, whatever number you have taken, so that will be printed is odd, right? And this here you will end with semicolon. Here also you will end with semicolon. They have not put semicolon in this printf line. You have to put semicolon, and then you will close the main also. The main we have opened here, the body of the main was opened here, curly bracket, and that main is ended here. Here. Can you understand this program, how it is written in C?
Yes,
ma'am.
So this is what we have done. How we have written a flowchart and algorithm for this program, and how we have converted into a C language code, right? Then another one is to find the product of first n natural numbers, right? Product of first n natural numbers. Suppose if you want to find or you want to print numbers from 1 to 10. Suppose a program is there to print numbers from 1 to 10. What will you do? Numbers from 1 to 10 you want to print, then what will you do? You keep on defining A, B, C, D, E, F, G, H, I, J, or 1, 2, 3, A is equal to 1, B is equal to 2. You'll do that.
We could add 1 to the number.
No, ma'am.
We could add 1, keep on adding until we reach 10.
Yes. So we will take only one input, right? One number. Sorry, we will define, suppose a variable. Suppose I we have declared, right? Declare I, integer type I, any variable you take, right? Take it I. Now what you will do in step 2?
Print.
You will first check if I, you can also say you can initialize I with 1, right? Declare and initialize I with 1. If I is less than equal to 10, you will compare. Do you understand? If I is less than equal to 10, I is less than equal to 10, I is 1 right now. Yes or no?
Yes, ma'am.
Yes, ma'am.
If yes, then what you have to do?
Increase it by 1.
Yeah, first print I. First print the I. If it is yes, then print I, right? And the next step will be to increment I. Then increment I means increment by 1. So I becomes 2 now, right?
Yes, ma'am. Yes.
Right. And then in step 5, go back to step 2. Go to step 2. Again you will compare. 2 is less than equal to 10. Yes. Print I and increment. Then it becomes 3. Then go to step this again. So then what will happen? 3 is less than 10. Yes.
3.
Print I, it will become 4. Then again it will keep on repeating these statements. This is known as loops. So if I is less than equal to 10, then go to step 3.
Step 3.
Else go to
Step 5.
step 6, we say, right? So we are now, if it is not less than equal to 10, then it will go to step 6. And what will be step 6?
Stop.
Right? Do you understand?
Yes, ma'am.
Yes, ma'am.
This is how you implement loops. So I am printing 1 to 10 numbers. So here also I will input, suppose I is equal to 1, initialize and input this, and then here this thing I don't require right now. So I require here a condition, right? So my condition box is
Third.
this one. So I will say, in my condition, I will say if I is less than equal to 10, right? If I is less than equal to 10, so I will have two things. One is no, and the other is yes. Right?
Yes, ma'am.
So I'm just so now if it is yes, you can also put here yes also. I'm just showing you text box you can take. If it is yes, Then what we have to do? We have to print it. So we have to print it. Print print I. So this we have printed, and we have to increment it also. So that is your processing box. So you increment it.
I equal to I plus.
This is there, so you can connect them. So this we have done, and it will after this it will go to what? It will go to stop only. This will go to no. This will go to where?
Step 3.
Again we have to go to the condition checking, right? Right?
From step 2.
After incremented, we again have to check that I is less than equal to 10. If yes, then again this is this. If no is there, then what we have to do?
Stop.
If then we have to stop. So you can just, we can take it here. Right? Simple. So this is known as your repetition. Repeatedly these steps will be taken care of. This is loop, and then if it gets greater than 10, then it will automatically stop. Right? Any problems?
No.
Right. So if you want to find the product of first n natural numbers means you have to give the n. Suppose 10, 20, whatever n you want to give. So you will input number n. So it can n can be 10, n can be 20, whatever n you want to give, and initialize product equal to 1. You can take product also, any variable also. So they have taken a product equal to 1, and then they have initialized the counter I is equal to 1. You can if you want to say counter, you can say counter also. If you want to say only I, you can say only I also. Right? So I is equal to 1 and product equal to 1. They have initialized. Then they compute the product. Product is equal to product into I. That is 1 into 1. What first happens, right? So product becomes 1 first. Then they increment the counter, that is I is equal to I plus 1. That is counter is now 2. I is 2 now. And they check whether the counter is less than equal to n. That means you have reached up to n or not. Do you understand? You have to calculate the product of n natural numbers. So up to n you have to go, na? So if your counter, that is I is less than equal to n, if it is less than equal to n, then you go back to step 5, compute the product, increment it, again check, compute the product, increment it, keep on doing until your n is reached. When the I becomes greater than n, so you will print the product of first and natural numbers and stop. Do you understand? Yes or no? What?
Yes, ma'am.
No,
So
ma'am,
how
I didn't understand it.
What did you not understand? Tell me.
And from the step 4, I didn't understand.
See, what do you need to find out first? Tell me.
And the product of first natural numbers.
First and natural numbers. So n you have to input n.
Yes, ma'am.
Suppose you have input n as 10, right? That means 10 natural numbers product you have to find out. 1 to 10 natural numbers product you have to find out. Okay?
Okay, ma'am.
Then what if you need to find out the product first, remember that your result will be in one variable. Right?
Yes,
Do
ma'am.
you understand? Your
Yes,
result
ma'am.
will be in one variable. So that variable we have taken product. Okay?
Okay, ma'am.
And why we have initialized it to 1, do you understand? If you
Because
don't initialize the product to equal to 1, it will by default be 0. Do you
yes,
understand?
ma'am.
So if
Yes,
you
ma'am.
multiply anything with 0, will it give you the product? It will give you 0 only.
Yes, ma'am.
So that's why we have given product as 1. Initialize it to 1. Right?
Yes, ma'am.
Then we had also taken a variable, counter variable I also. Why we have taken I? To count the number of steps. First, then 2, second, then third, then fourth. It will keep on going until end we have to go 10. Do you understand?
Yes, ma'am.
So I also we have initialized to 1 because I will be 1, then it will go to 2, then it will go to 3, right?
Yes, ma'am.
So that is the counter. So we need to find the product or not?
Yes, ma'am.
Yes.
We need to find the product. Yes.
So product, we are writing product, that is our variable where the result will be. So product is equal to product into I we are doing. So product is 1. Yes.
Yes, ma'am.
And I is 1. So 1 into 1 will be first 1. Product will be 1.
Yes, ma'am.
And then counter will be incremented. That means I is equal to I plus 1. That means I becomes 2.
Yes, ma'am.
So counter is your I. So 2 is less than equal to 10. Your n is 10 now.
Yes, ma'am. Yes,
So
ma'am.
2 is less than equal to 10. So you will say yes. So it will go to, again it will calculate the product. So product is 1, earlier product was 1. Now product is equal to 1 into 2 because I is 2 now. So it will become 2, product will become 2 now.
Yes, ma'am.
And I will be incremented, it will become 3.
Yes, ma'am.
And 3 is less than equal to 10.
Yes, ma'am.
Again it will go here to compute the product. Product is equal to, product was 2 now, 2 into 3.
Yes,
Because
ma'am.
I is 3 and product was 2. 2 into 3 is 6. Product is now 6. Okay?
Yes, ma'am.
And I will increment, it will become 4. Again 4 is less than equal to 10. Yes, it will go here. Product will be calculated. 6 was the product into 4. I is 4 now. 6 4s are 24.
Yes, ma'am.
Product is 24. Again it will keep on multiplying until 10 is reached here. Do you understand?
Okay, ma'am. I understand.
And when I becomes greater than 10, so it will print the product, final product output, whatever comes in this product, right? It will print and end.
And so after the 24, it will end.
After
we get the 24, it will end.
After whatever up to 10, whatever multiplication, whatever answer comes out to be after your 10, whatever answer comes out to be, right? That product will be printed. That is printed outside the loop, not inside.
Yes,
The
ma'am.
question I have done here, we have printed inside the loop. Can you see that? I have printed inside the loop. Yes?
Yes, ma'am.
And here it is printed outside the loop. Can you tell me why? In that question I have printed inside the loop, and in this question they have printed outside the loop. When
And
the
because
loop ends.
we don't need the answer after the 10.
In our previous question, we wanted to print 1 to 10 numbers. To print 1 to 10 numbers, the printing should be inside the loop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So it should be inside the loop. But here I want to print the product of first and natural numbers. So all the numbers should be multiplied, then the product should be printed. So the numbers are multiplied in the loop, but the answer is given outside the loop. Right? Because I need the final answer. I don't need the mid answers, one by, suppose 1 into 1 is there, then print the product will be 1. Then 2 into 1 is there, then it will print 2. Then 3 into 2 is there, so it will print 6. I don't want that. I want the final answer. That's why outside the loop. Do you understand? Everybody
Yes, ma'am.
understood?
Yes, ma'am.
How loops are implemented. So same way in the flow chart, they have taken the input n, they have initialized I to 1, product to 1, then they are finding the product is equal to product into I, and then they are incrementing I, and then they are checking whether I is less than equal to n. If yes, if I is less than equal to n, just hold on for a second. Sorry. Right. So here they have written it wrongly actually. If it is I is less than equal to n, then yes, it should go here. It should be yes here. Do you understand? Are you able to understand, everybody? In your book or the soft copy, it is given wrongly. If I is less than equal to n, then you have to, if yes, you have to find the product, increment, again find the product, increment in yes. And in no, when I is not less than n equal to n, then you have to print the product. Do you understand?
Yes, ma'am.
Yes should be here, no should be here. Yes. They have given it wrongly and then stop. So this is how you implement loops in your flowchart. Any problems?
No, ma'am.
Right. Same way they have implemented in your C also. They have included the header file. They have given the function main, and in the body of the main in curly brackets they have initialized n and I as integer, and the product is equal to 1. Product is your output in which you have to take the output, that is also initialized to 1. Then they are saying printf enter number n, and scanf %g %n, they are taking the input. Suppose 10 we have given. Now in loops they have taken for loop. There is also while and do while also, but they have taken for loop. For loop is better. For first, in for it is initialization, that is I is equal to 1, I is initialized to 1, semicolon, the condition is given I is less than equal to n, semicolon, I plus plus, and then I is incremented. So initialization, condition, and increment, decrement is the syntax of your for. So first initialization you have done, then your condition is there, then increment. So in the body of the for, you will find the product. It then automatically in because increment is given here, it will become 2. 2 is less than equal to 10. It will compare. Then again it will find out multiply 2. Then I will again be incremented. It will 3. So it keeps on doing until 10, and after 10, when I becomes 11, so it will come out of the loop and it will printf product of first n or 10 natural numbers is, it will print the product. Here they have given this product will be printed. Final answer. Right? Any problems?
No, ma'am.
Right. So this one of the question of this kind of a question may also be in your assignments to make an algorithm or something like that. Right. To find the sum and average of marks obtained by 20 students in some course or subject of a course. Now, do you know the concept of arrays? If I want to keep
Yes, ma'am.
20 student marks, so what do I have to do? If I want to keep 20 students marks and find the sum and average of the marks, Do I need to declare 20 variables? Keep on declaring 20 variables for the students. A, B, C, D, E, F. What do I do? That will be too cumbersome now.
Yes, ma'am.
Right. So we need to have arrays. Arrays concept is that you can have one variable, one array, name of the one array, and you can have 20 contiguous locations in a single array. Name will be A, array's name will be A, but you can access the 20 locations in that array. So it is a collection of similar elements. Actually, it is a collection of similar elements. So array is known as a collection of similar elements. So how you can access the elements? A0, the index, there is index in arrays. So it starts from 0. So 0th index will be the first element, 1th index will be the second element, so on. So 0, 1, 2, 3. So you will keep the 20 students marks in the index 0, 1, 2, 3, 4, 5, 6, 7, 8, like that. You understand? You don't have to declare 20 variables for that. With one variable only, you are able to keep 20 students marks in an array. Do you understand?
Yes.
Yeah. So when we initialize an array, how do we initialize an array? We are taking an array name as S, and we will be keeping 20 students marks in that array. So S in square brackets 20, if we are writing, that means the array has 20 contiguous locations, right? From 0 to 19. Do you understand that? Indexes from 0 to 19, 20 contiguous locations will be there in this array. Understood? Then we are taking a sum also as 0 because we need to find the sum, and we if you also have to take average also. You can take average also, and you can keep it is equal to 0. Do you understand? Sum and average, both variables you can declare. They are not declared here, but you can take average also. Then we are also taking a counter. You can say I is equal to 0. Counter we have taken. Then now we compute the sum. Sum is equal to sum plus S counter. Why S counter we have given? This counter will be the index value. So first will be 0. So the sum is calculated. Whatever value you are taking in your array, the first will be added in the sum. So the first value is S0. So first value is the counter number 0. The value is at 0. Whatever value will be there will be added in the sum, and the counter is incremented. The second, then it will check whether the counter has reached less than 20. Yes, it is less than 20. Again, it will go here, compute the sum. The second element sum will be added. Then the counter is incremented. Check the counter. Then the third element is added to the sum. So it keeps on going until the counter becomes 20, and when it becomes 20, it will go come out of the loop, and it will calculate the average, which is equal to sum divided by 20. Average is what? Always total divided by the number of elements now. So sum divided by 20, and you can print the sum and average, right?
Right.
Any problems? So they have done here input marks of 20 students in S20, that is an array. You have input 20 student marks. Sum and counter you have taken as 0, and then you calculate the sum is equal to sum plus S counter. The first index value will be added in the sum, and the counter is incremented. Counter is compared with 20. If it is not 20, it will again add next counter with the sum. Then a counter is incremented. Then again it will keep on adding until 19. Then when 20 is reached, it will come out of the loop, and it will calculate the average, and you can print the sum and average and so on. Right? So in how in main it is done. So first they have declared I and sum, and they have declared an array S20, right, and a float average, because average will always come out to be in decimal point. So average is float. Float is a data type which keeps a decimal number. Integer doesn't keep a decimal number. And sum is 0. And then they are saying enter. Acha, if you want to enter marks of 20 students, again you have to use for loop to input a loop to input marks of 20 students. So how do we input? We'll say for I is equal to 0, initialize I to 0. Condition is I should be less than 20 and I plus plus. So printf percentage D is equal to I plus 1. That is first element we are inputting, and that is scanf. Input is this SI. Percentage D comma ampersand SI. So an integer input will be put in this location I, that is 0th location. The input will be put. Then again increment I will be 1. So at 1th location it will be your input will be there, then 2th, then 3th until 19. 0 to 19 locations or 20 locations array has data has been put. Now if we are saying I is equal to 0 and we are comparing while I is less than 20, again while is another loop like for, but here your increment decrement has to be done inside the body of the loop. I is equal to 20, your increment, your initialization is done here, and then condition is given with while I is less than 20, then you calculate the sum is equal to sum plus Si, or your array element 0 will be here, and then it will I will be incremented, then it will be compared with this, then the second element will be added, then again compared, then third element, then fourth element, and keep on. I plus plus means increment, keep on incrementing, adding, keep on incrementing, added until 19, and when 20 is reached, it comes out of the loop and calculates average is equal to sum divided by 20, and it will print the sum of marks for 20 students is this sum, percentage is sum, and average marks of 20 students. 0.2 F means float, percentage D is for integer, percentage F is for float, and 0.2 means 2 decimal places. The average will be printed. Can you understand this or not?
Yes, ma'am.
Class, any problems?
No, ma'am.
You have to practice yourself. See, understand this. See, right, dekho. Here in your check progress 1, you have to write an algorithm for solving the following problems to calculate the area of a rectangle. Can you make the algorithm for this?
Yes,
What is area of a rectangle? Length
We
into
are
breadth.
trying.
L into
Right?
V.
Then to find the sum of first and natural numbers. This already you have done above. Right? Then you have to make the flowchart for both of them.
Yes, ma'am.
So try these questions so that you are familiar with the algorithm and flowchart also. Right. The next part is concept of programming language, which we'll be doing tomorrow, not today. So please go through this algorithm and flowchart. This is also an important part of your thing, and other part we will be doing tomorrow. That will be your concept of programming language. We'll be studying about variables, constants, data types. What are those? So we'll be studying that. That is your next part, right? Any doubt?
No.
Anybody is having any doubt?
No, ma'am.
So everybody has written their enrollment number.
Yes, ma'am.
Yes, ma'am.
Yes, Vishal, what is your question? My name is written on your schedule also.
Ma'am. Hello.
Yes.
Ma'am, can you please turn on your camera?
My camera in my system actually is not working. In my mobile it is working. I am right now on my system actually.
क्या
Okay,
करना है
sorry.
कैमरा ऑन करना है?
No, I haven't seen